In this section, you're going to be learning about f of x equals e to the x, your natural exponential function. And we're going to be reviewing the properties that you learned in Algebra 2 and Pre-Calculus. And we're going to learn new calculus rules for differentiation. You're going to love this section. So we need to remember that f of x equals e to the x is the inverse function for ln of x. ln was created for e to the x so that we could deal with those unknown exponents. And that inverse relationship is shown by your y equals e to the x if and only if x equals ln of y. This is your looping rule. Remember, we called it follow the loop. And so that we could say log base e of y is equal to x. And if I write this as ln of y is equal to x and I follow my loop, we have base e to the x is equal to y. We can loop it back. So remember that inverses undo one another, and this is the primary reason we have them. On this particular slide, I've included just a couple of review items from Algebra 2. Your exponent rules for multiplying and dividing. Don't forget that e is just a number, so don't panic when you see it. And you need to remember things that we learned in pre-cal, like domain, how to graph, the fact that the function is concave up on its entire domain, and the new calculus ideas of limits. And I'll be talking about both concavity and limits in the next slide as we go over the graph. So the basic graph of e to the x has an asymptote running along the x-axis, which is its guideline. It follows that asymptote until it sees that 0.01, which causes it to shoot off in its exponential behavior. Now, when we were talking about the limit as x approached negative infinity of e to the x, we were looking at the far end behavior on the left. So right here as x is heading off to negative infinity. And so as x heads to negative infinity, notice that that graph gets closer and closer to 0. Then as we look at the right side of the graph, this is end behavior that you learned in pre-calculus. So limit as x approaches positive infinity, as the x's get bigger and bigger, the y's get bigger and bigger, and so this function shoots off to infinity on the right side of the graph. Now, concavity. Concavity talks about curvature. And so notice that this graph is curving up. So this area right here, if I were to pour a glass of water, it would actually hold water like a cup. It's concave up over its entire domain. In this section, you're going to have to review your graphing transformation rules for exponentials. So let's go over those real quick as well. So notice that now I'm changing the function from f of x equals e to the x to f of x equals negative e to the x minus 2 plus 3. The negative is an x-axis reflection. So now this graph is skimming under the x-axis, and then the 2 is positive, and so it is shifting right 2 units. The 3, also positive, shifts up 3 units. So my asymptote, I'm going to wait to put it in at the end because it's going to actually shift up 3 units with that positive 3. So I have my shifting point was at 0, 1, and I'm going to take that point and reflect it across the x-axis. So now it's at 0, negative 1. Taking that same point, I'm going to shift right 2. So it's now at 2, negative 1. And then I'm going to shift up 3, which is at 2, 2. So my curving point happens right there at 2, 2. My horizontal asymptote went from 0 to 3, and it's skimming underneath the asymptote, heads towards that curving point, and that's what causes that exponential growth or decay. Now here's the part I told you you were going to absolutely love. The derivative of e to the x is e to the x. That's right, it doesn't change at all. Then if your exponent changes from 1x to the first power to anything else, that becomes a u. That's a chain rule. And so you know that we do the normal derivative, which is going to be e, keep your exponent e to the u, and then derive what the u is. So u prime is multiplying out front. So that's your chain rule. So in this problem, I've got u is equal to 2x, so my u prime is just 2. This is normally done in my head, and I see this as this y prime. My 2 is going to be in front, and it's e to the 2x. I did not use a power rule. I used a chain rule. E to the whatever times the whatever prime. So let's go over this one more time. We have y equals e to the negative 3x. So my u is negative 3x. My u prime is negative 3. My derivative, y prime, is equal to negative 3 e to the negative 3x. E to the whatever times whatever prime. So your slides are getting gradually a little more difficult. This is just another e to the u, but my u happens to be a power rule. So now I've got y is equal to, y prime is equal to deriving my u prime negative 2x e to the u negative x squared. Now let's combine the product rule along with our e to the u. So I have y prime, and I'm going to derive the x squared, which is 2x, keep the e to the negative x, adding, keep the x squared, and derive e to the negative x, which is going to be negative e to the negative x. So I'm going to factor out, now I'm simplifying, e to the negative x, and I can also take an x. And I'm left with 2 minus x. And so we don't want negative exponents in our answer. I have x times 2 minus x all over e to the x. Don't you love this section? Okay, let's make it a little more fun. I can actually do this problem 2 different ways, so we'll see how much room I have on the slide. The first thing I'm going to do is I'm going to break apart my ln. So I'm using my ln properties, and division is ln of the top minus ln of the bottom. Then my ln rule, my ln of u rule is u prime over u. And so I have y prime is equal to 1 plus e to the x in my denominator, and then the derivative of 1 plus e to the x, just e to the x, because 1 is 0, e to the x is just e to the x. Minus, again, over 1 minus e to the x, and then the derivative, negative e to the x, so minus a negative becomes plus a positive. Now I'm going to just do a common denominator. I'm cleaning it up. And this is all over 1 plus e to the x times 1 minus e to the x. Okay, the e to the x is common. I'm going to factor it out. And I'm left with 1 minus e to the x plus 1 plus e to the x. On top, the e to the x's cancel. All over 1 plus e to the x, 1 minus e to the x. And so I've got y prime is equal to 2e to the x over 1 plus e to the x, 1 minus e to the x. Okay, I'm going to do this problem in a different way in just a second, but I want you to copy this down. Okay, so I promised you I would do this in another method. So I'm going to leave it as a quotient, and I'm going to use the derivative rule for ln u. And so that's going to give me u prime over u. My u is a fraction, so it's the same thing as saying u prime times 1 over u, which means I'm going to reciprocate my fraction. So because we don't divide by fractions, we multiply by their reciprocal. So as I derive, I have y prime is equal to 1 minus e to the x over 1 plus e to the x. That's my 1 over u. And then doing my quotient rule, I have e to the x, keep the 1 minus e to the x, minus 1 plus e to the x, keep it, and derive the negative e to the x. So that negative becomes a positive, so I'm going to change that now, and then this is all over 1 minus e to the x squared. So I'm looking at it and saying, oh, there's some stuff that I can take out that's common. This is not adding, just so that you know. I changed that to a positive. This is really multiplying, so I'm going to scribble that out so we don't get confused. So looking at what's common, I can take out an e to the x, and I have y prime is equal to 1 minus e to the x times e to the x, which I'm taking out, and I'm left with 1 minus e to the x plus 1 plus e to the x. The e to the x's cancel. And this is all over 1 plus e to the x, 1 minus e to the x squared. Now, this squared is going to cancel with this 1 minus e to the x. So I'm simplifying, and I get y prime is equal to e to the x, and then 1 plus 1 is 2, so 2e to the x, all over 1 plus e to the x, 1 minus e to the x, which is what we got on the previous slide. So now it's your turn. These are the questions that you're going to turn into me. So you're going to do the derivative for y equals e cubed ln x. Remember what represents a number and what represents a variable. You need to be very clear on that. Then your second question, y equals ln e to the x plus e to the negative x over 2. Again, remember what constants are and what variables are. It makes it a lot easier. And then your homework is not too difficult. I hope you really like this section. It's one of my favorites. I'll talk to you later. Bye.